Process of cavitation in pumps. Cavitation are a vacuum aspiration and undesirable hydrodynamic effect which occurs when water or other liquid fluid passing at high speed along a sharp edge, producing a decompression of the fluid. Specifically, a pump occurs when the fluid has difficulty entering the suction zone, so that the pressure drops in this duct, so that if the pressure is less than the vapor pressure of the fluid itself, will lead to the formation of bubbles which are called cavities. Passing such cavities, the suction to the discharge of the pump are suddenly compressed under very high dynamic pressures, at the end just exploding by exploiting micro-tear of the pump body, leading to spoilage, to poor fluid supply and rapid aging of the pump, with loss of its pumping capacity and pressure boosting. The NPSH, a net positive suction head, is a measure of the energy available at the pump suction above. The energy that would result in the onset of cavitation. Being an incompressible fluid, we can refer to this term to the suction head available. For this two terms are the NPSH available and the required NPSH. The equation of the NPSH available consists of two terms. The former does not depend on the pump. Quadle not only depends on the installation, specifically the height at which you place the pump and suction conditions. The second, reference to the losses due to friction in the suction. It is represented graphically. The equation of the required NPSH consists also of two terms. The former refers to the kinetic energy to the pump inlet. The second to the hydraulic losses by friction and shocks from the point of entry to the impeller, and the minimum pressure point is well represented, for which cavitation occurs not be fulfilled that the pressure in the suction side of the pump is greater than the vapor pressure of the fluid, so that the difference of the two terms should be substituting to obtain that cavitation occurs not be fulfilled that the difference between the available and required NPSH is positive. Plotting the two curves, we see that cavitation limit is in the two cut-off curves. Thereafter is the phenomenon A. Pump cavitation, two zones. Suction cavitation occurs in the eye of the impeller, and suction occurs when the pump is in a condition of low pressure. High vacuum causes the liquid is transformed into steam to the impeller inlet. This steam is conveyed to the discharge side of the pump, where the gap disappears in the fluid. Vapor is compressed again due to discharge pressure. Then occurs a violent implosion onto the surface of the impeller. This type of cavitation is caused by excessive suction of that the NPSH becomes insufficient by an increase in pressure loss. Impulsive cavitation occurs between the impeller blade tip and the casing, where the body. The high-pressure discharge causes most of the fluid flow inside the pump rather than out the discharge zone. This phenomenon is known as slippage, as the liquid flows around the impeller must pass at very high speed through a small opening between the impeller and the pump breakwater. This velocity, caused by the vacuum in the seawall, which causes the liquid to produce a vapor, occurs when the pump discharge is very high. This typically occurs in a pump which is operating at less than 10% of its optimum. Several cavitation problems it can bring. The collapse of the cavities assumes the presence of large amounts of energy which can cause extensive damage. Cavitation can damage almost any material. The pitting caused by the collapse of cavities produces a huge wear on the different components and can dramatically shorten the life of the pumps or propellers. Creation and collapse of the bubbles creates friction and turbulence in the liquid. This contributes to a further loss of performance on devices subject to cavitation. As a consequence of the cavities is generated discreditable noise. In fact, this noise so particular is a way to remedies to prevent cavitation, good machining and conservation status of the pump, that the suction pipe is wide and short and is inserted into the perfect fluid with the pump seal. Do not start the pump having very cold fluid heated to the temperature appropriate. Do not work with very high fluid temperatures, that the pressure in the suction is as stated by the manufacturer. Ensure proper fluid level in the reservoir.